So good morning, welcome back students. So today we have module 2 of fluid properties. So yesterday we started fluid properties and we have an introduction to fluid properties. So I will summarize what we discussed yesterday in brief. So we stated that the matter can exist in any of the three states, namely solid, liquid or gaseous, and the same substance can exist in any of these three states in natural conditions. And the classical example we stated was water, which can exist in solid form as ice, in liquid form as water, and in gaseous form as water vapor. And then we told about the differences between solids and fluids. So we defined what a fluid is, and fluid is, it can represent a liquid or a gas. We differentiated between the characteristics of solids and fluids in terms of the ability to resist external forces, and then the spacing between the molecules, the force of attraction that exists, and regarding the shapes taken by the fluids, and then regarding the volume. And liquids are generally treated as incompressible under ordinary conditions, whereas gases are highly compressible, and even a slight change in temperature or pressure will make a huge change in the volume of a gas, and hence the mass per unit volume will change. So in due course we will unfold the various properties in the lectures to come. And then we distinguish between a real fluid and an ideal fluid. So an ideal fluid is the one which has zero viscosity and zero surface tension. So we do not have any such ideal fluid in practice. All are real fluids, but the fluids like water or air which have less viscosity, they are considered as ideal fluids for the sake of discussion and consideration. So today we move into the properties. So in the modules or lectures to follow, we will unfold the various properties, fluid properties, and discuss at length. Now today in module 2, so before we start with the properties in detail, let me list the various properties that we will be discussing in this particular topic. So first we will be discussing on mass density, then specific weight, then specific volume, specific gravity. So these four things will be covered in this module, and then in the next module we will be discussing on viscosity, then a related property of viscosity called kinematic viscosity, then we will see about vapor pressure, then compressibility, then surface tension and capillarity. So these are the various properties which are of interest, which we will be discussing. And today in module 2 we will be covering the first four, that is mass density, specific weight, specific volume, and then specific gravity. So let us first take mass density of a fluid. So mass density is also called as specific mass. The other name for mass density is specific mass. So how it is defined? So it is defined as the mass which the fluid possesses per unit volume. So mass density can be written in mathematical form as mass density is equal to mass per unit volume, mass divided by volume. So let us also discuss the units of measurement as well as the dimensions of each of these parameters or properties in detail. And as an engineer, right, if you are an engineer, if you are pursuing an engineering degree, you should be well conversant with unit conversion. So you have the FPS system, foot pound and second, or MK system, meter kilogram second, and then now we have the system international SI system of units, in which the force is expressed in newtons, the length in meters or millimeters, and then of course time in seconds. So you should know the conversion. See, for example, if you are a civil engineer, if you are designing a building, still a residential building you take, for example, a room dimension is given as say 10 feet by 6 feet or 10 feet by 8 feet. So feet, that is a British system. So you should be able to convert to the SI system also, and from SI system you should be able to convert to the FPS system. So even though strictly speaking, technically we follow the SI system for documentation, still when it comes to the ground level, in order to make the customer understand, we use the FPS system. We use say even the measurement, the length measurement in foot. So the mass density or specific mass, it is called, is defined as the mass which the fluid possesses per unit volume. Now, what is the unit of mass? The unit of mass in SI system is kilogram mass and volume is in meter cube in SI system. So the unit of mass in SI system is kilogram mass. So you should know, say suppose if I ask what is your weight, say you say 50 kilograms. So that kilogram is different from this kilogram. So that kilogram is a force quantity in MK system. We are using MK system. We do not normally tell our weight in newtons. Nobody will understand. So you have to just note that this kilogram mass is a SI unit of mass. This is very much different from the kilogram which we use for telling our weight or the weight of a substance, or when you buy a grocery or vegetable from a market, we use kilogram. That is kilogram force, which is a different system, that is MK system. So whereas the unit of volume, that is meter cube. Say to understand the physical nature of volume, say for example you have a cubicle, that means it has a length, it has a breadth and it has a height. So length, it is in meters, then breadth is in meters and height is in meters. So meter multiplied by meter, you get meter cube. So that is a concept, the physical concept of volume. கொள்ளளவு அப்படின்னு தமிழில் சொல்கிறோம். So mass density, it is mass divided by volume. Kilogram mass per meter cube is the SI units. And we always give a notation for each of these parameters which we will be using or adopting in the subject. So here mass density is denoted by the Greek symbol, that is rho. The pronunciation is RHO, rho. And again, say mass density of water, say at 4 degrees Celsius, the temperature is important. So particularly when you are giving the mass density of a liquid, the temperature is important. Say for example, mass density of ice. mass density of water in liquid form, mass density of water vapor. So they are a little different. So even if you have the same volume, the mass slightly differs with regard to temperature. So I is at 0 degrees Celsius, whereas liquid water, the standard temperature we quote is 4 degrees Celsius. So mass density of water at 4 degrees Celsius is 1000 kilogram mass per meter cube. So there is, when I say the mass density, I need not always specify mass every time. So when I say kilogram per meter cube and it is density 1000, mass density means the kilogram refers to the mass volume and not the force, mass unit and not the force unit. So mass density of water at 4 degrees Celsius, that is the standard temperature, is 1000 kilogram mass per meter cube. So now let us discuss on the factors affecting mass density of a fluid. See, we have already seen that a fluid is composed of, any substance for that matter or any matter is composed of numerous molecules, right? Millions of molecules. So any fluid is composed of molecules, and any molecule or every molecule has a certain mass, So the mass density of a fluid is proportional to the number of molecules which the fluid possesses in unit volume. So a fluid is composed of molecules, and every molecule has got a fixed mass or a certain mass, and therefore you can say that the mass density of a fluid is directly proportional to the number of molecules present in the unit volume of fluid. Then also I told earlier that whenever you tell about the mass density of a fluid, the temperature is very, very important. So with regard to temperature, the mass density of the fluid will change. In case of liquids, the variation may be little, whereas in case of gases, even for a slight change in temperature, the change in mass density will be huge. So mass density depends upon the temperature of the fluid. It's very important. So when the temperature increases, what happens? The molecular activity or the molecular mobility increases. That is, the molecules get more freedom to move from one place to another within the mass. So when you increase the temperature of the fluid system, the molecules become active, or the molecular activity increases, or the molecular mobility increases. The molecules have more freedom to move from one place to another, and therefore what happens? It disturbs the spacing between the molecules. So when the molecules are free to move, the spacing increases. So what happens? In unit volume, there are only fewer molecules of fluid, and therefore what happens? The mass density of a fluid decreases with increase in temperature. Suppose when I ask a question, you state the reasoning for the decrease in mass density with increase in temperature. So உஷ்ணம் அதிகரிக்கும் போது mass density குறையுது. எப்படி குறையுது, எதனால குறையுது அப்படிங்கிறதுக்கு தான் இப்போ விளக்கம். ஸோ மாஸ் டென்சிட்டி அப்படிங்கிறது உஷ்ணத்தை பொறுத்து இருக்குது, ஃப்ளூயிடோட உஷ்ணத்தை பொறுத்து இருக்குது. ஸோ உஷ்ண நிலை அதிகரிக்கும் போது இந்த மாலிக்யூல்ஸ் மூவ் ஆகிறது அதிகரிக்குது. ஸோ மூவ் ஆகிறது, அது மொபிலிட்டி, அந்த ஒரு இடத்துலேருந்து இன்னொரு இடத்துக்கு போகக்கூடிய தன்மை அதிகரிக்கும் போது இரண்டு மாலிக்யூலுக்கு இடையில் இருக்கக்கூடிய அந்த ஸ்பேசிங் டிஸ்டன்ஸ் வந்து அதிகரிக்குது. அப்போ அதிகரிக்கும் போது ஒரு யூனிட் வால்யூம், ஒரு 1 மீட்டர் கியூப் ஆஃப் அ ஃப்ளூயிட் அப்படின்னு எடுத்தோம்னா அது இருக்கக்கூடிய நம்பர் ஆஃப் மாலிக்யூல்ஸ் வந்து குறையுது. ஏன்னா ஸ்பேசிங் அதிகரிக்குது, ஸோ குறையுது. ஸோ அப்படி குறையும் போது the mass density of a fluid decreases. So with increase in temperature, and because of the increased molecular activity, and because of the less number of molecules in unit volume, the mass density decreases with increased temperature. So volume fixed வச்சிருக்கிறோம் 1 meter cube. When the temperature increases, the mass decreases. So with increase in temperature, the mass decreases in unit volume. So volume fixed வச்சிருக்கிறோம், and therefore the mass density decreases with increase in temperature. Whereas if you take a fluid, that is a gas வந்து easily compressible, you can compress it easily. When you release the compression, it tends to expand. So when it is pressurized அப்படினா you are compressing. When it is compressed, what happens? Because of the increased again molecular activity, the molecules come closer together. Here the molecules come closer together. in a given volume. So once they come closer together, that means the molecular spacing decreases. So you are packing more number of molecules within a unit volume. And therefore, what happens, it is expected that with increase in pressure, the mass density of fluid will increase. So temperature increase ஆனிச்சுன்னு சொன்னா அந்த molecular mobility increase ஆகுது, அதனால spacing கூடுது, spacing கூடும்போது ஒரு யூனிட் வால்யூமில் இருக்கக்கூடிய நம்பர் ஆஃப் மாலிக்யூல்ஸ் குறையுது, அதனால மாஸ் குறையுது. ஸோ மாஸ் டென்சிட்டி டிக்ரீசஸ் வித் இன்க்ரீஸ் இன் டெம்பரேச்சர். வேற ஆஸ் அதே ப்ரெஷர் எடுத்தோம் அப்படின்னா, லிக்விடை விட்டுருங்க, ஒரு கேஸ் எடுத்துக்கிறோம் அப்படின்னு சொன்னால் கேஸஸ் ஆர் ஹைலி கம்ப்ரெசிபிள். ஸோ வென் யூ ஆர் ப்ரெஷரைசிங், because of increased molecular activity, the molecules come closer together. So when they come closer together, the molecular spacing decreases. The intermolecular spacing decreases, குறையுது. குறையும் போது என்னன்னா யூனிட் வால்யூமில் இருக்கக்கூடிய அந்த மாலிக்யூல்ஸ்னுடைய அளவு அதிகரிக்குது. The number of molecules increases and therefore the mass density increases with increase in pressure. So we can generally conclude that the temperature and pressure affect the mass density of a fluid. So with increase in temperature or increase in pressure, the molecular mobility increases and therefore the mass density changes, it varies. So in the case of gases, with increase in temperature and pressure, the mass density increases. Whereas in the case of liquids, which are generally incompressible, so you cannot pressurize it because it is incompressible. Whereas the temperature can have a slight effect on mass density. With increase in temperature, the mass density decreases. That is in the case of a liquid. Whereas in the case of gases, ஒரு வாயு எடுத்துட்டோம் அப்படின்னு சொன்னால், உஷ்ணம் அதிகரிக்கும் போது, அழுத்தம் அதிகரிக்கும் போது மாலிகுலர் மொபிலிட்டி அதிகரிக்குது. அப்போ மாலிகுல்ஸ் வந்து க்ளோஸாக பேக் ஆகுது. பேக் ஆகும்போது ஸ்பேசிங் குறையுது, அந்த இடைவெளி குறையுது. இடைவெளி குறையும் போது நிறைய மாலிகுல்ஸ் வருது யூனிட் வால்யூமில், அப்போ மாஸ் டென்சிட்டி அதிகரிக்கிறது. ஓகே, now let us go to the next property, that is specific weight of a fluid. Specific weight-க்கு இன்னொரு பேர் கேட்டிங்கன்னா weight density. மாஸ் டென்சிட்டிக்கு ஸ்பெசிஃபிக் மாஸ்ன்னு சொன்னோம், ஸ்பெசிஃபிக் weight-க்கு இன்னொரு பேர் வந்து weight density. So how it is defined? It is specific weight is defined as weight per unit volume. Mass density la mass divided by volume சொன்னா, இங்கே weight divided by volume. So weight அப்படிங்கிறது it is a force quantity. வெயிட்ங்கிறது ஃபோர்ஸ். ஸோ ஃபோர்ஸ் அப்படின்னா அதனுடைய எஸ்ஐ யூனிட் வந்து, ஃபோர்ஸோட எஸ்ஐ யூனிட் வந்து நியூட்டன். ஸோ வெயிட் பர் யூனிட் வால்யூம். ஸோ அதனுடைய நொட்டேஷன் வந்து கிரீக் சிம்பல், தட் இஸ் காமா. காமா அப்படிங்கிறது ஒரு ஆர் மாதிரி, ஸ்மால் ஆர் மாதிரி மேலே ஒரு கொம்பு போடணும். ஸோ அதனுடைய ப்ரொனன்சியேஷன் காமா, GAMMA போட்டுக்கோங்க. So in SI units, the specific weight is expressed as Newton. So weightங்கிறது ஒரு ஃபோர்ஸ், ஃபோர்ஸோட SI யூனிட் வந்து நியூட்டன், வால்யூமோட SI யூனிட் வந்து மீட்டர் கியூப். ஏற்கனவே பார்த்தோம். அப்போ நியூட்டன் பர் மீட்டர் கியூப். இது MK சிஸ்டத்தில் எப்படி சொன்னோம் அப்படின்னா கிலோகிராம் பர் சென்டிமீட்டர் கியூப். மேபி கிலோகிராம், இங்கே கிலோகிராம்ங்கிறது கிலோகிராம் ஃபோர்ஸ், இட் இஸ் அ ஃபோர்ஸ் குவான்டிட்டி. ஏற்கனவே சொன்னேன் நம்மளோட வெயிட் என்ன, ஒரு 50 கிலோ 60 கிலோ அப்படின்னு சொன்னால் அங்கே வந்து கிலோகிராம்ங்கிறது இட் இஸ் அ ஃபோர்ஸ் குவான்டிட்டி. ஓகே, அகெயின் டேக்கிங் வாட்டர், பிகாஸ் வாட்டர் இஸ் கன்சிடர்ட் ஆஸ் தி ஸ்டாண்டர்ட் லிக்விட் in any of our discussion. So specific weight of water, again you should quote the temperature. Temperature is important. With respect to temperature, there will be slight variation in the mass density or specific weight. So specific weight of water at 4 degrees centigrade can be taken as 9810 Newton per meter cube. 9810 Newton per meter cube. Suppose if we want to tell in MK system, say kilogram per meter cube, for example, kilogram per meter cube, right? It will be 1000 kilogram per meter cube. Kilogram force, here it is kilogram force. So specific weight of water in SI unit, it is 9810 Newton per meter cube. This is in SI system, whereas in MKS system, meter kilogram second, it is 1000 kilogram force per meter cube. Okay. Whereas 1000 kilogram per meter cube, we say that is a mass unit for mass density. So there is a difference. So 1000 kilogram per meter cube is mass density, that is kilogram mass. 1000 kilogram force per meter cube, that is specific weight. So the units are different. So you should be able to distinguish between the units and also convert from one unit to another unit. Let us also derive the dimensions. So let me again go back to the previous slide. So if you take mass density, so the basic dimensions which you will be employing are M, L and then T. There are some other basic dimensions also. So dimensions means the unit is not important. So we will not be confused. So M is the dimension for mass. So be it in kilogram mass or metric slugs, we say MSL or any other thing. The dimension for mass is M, capital M. The dimension for length, be it in millimeters or meters or yards or foot or meter, centimeter, the dimension is L. And time, be it in hour or day or seconds or minutes, the dimension is T. So MLT, that is these three dimensions we can use. Or we can use even the FLT system, that is F, instead of mass we can use force. Then that is, if the unit of force can be Newton or kilogram force or anything, right, or pounds, still we can use the dimension F and the length again in L and the time in T. So we can use a FLT system or a MLT system. Now mass density of fluid. So again I recollect the definition. We defined mass density as mass per unit volume. So mass, the SI unit is kilogram mass. So here mass, the dimension is M, and volume, as I said, it is meter cube. So meter cube means it is L cube. L cube. So mass density dimensions will be M, L power minus 3. So the dimensions of mass density is M, L power minus 3 or M divided by L power 3. Now let us take specific weight. Let us derive the dimensions of specific weight. Now specific weight, it is defined as weight per unit volume. So weight is a force quantity. So if you express in, if you use the dimensions FLT, the dimensions of specific weight will be F divided by L cube. Say I want to express, I want to use MLT system. So how to do? So let me reserve it for the time being, and then after going through the discussion in the next slide, we will come back to the dimensions of specific weight using MLT system. Okay. Okay, now let us derive the relationship between mass density and specific weight. Now we have already discussed that the weight of a fluid is the product of its mass and the acceleration due to gravity. So weight of a substance is the product of the mass multiplied by the acceleration due to gravity. So how can you express specific weight? Now specific weight is what? Specific weight is weight by volume. So if you divide this by volume, weight by volume, the left hand side is divided by volume. So right hand side also you divide by volume. So mass by volume becomes this mass density, then G. So you have specific weight is equal to mass density times or mass density times the acceleration due to gravity times mass density, G times rho. So weight, we know weight is the product of mass and acceleration due to gravity. So if you divide the left hand side as well as the right hand side of this equation, that is W equal to mg, it becomes W by, you divide by volume, so m by v into g. So W by v is the definition of specific weight. m by v, that is mass by volume, is the definition of mass density multiplied by acceleration due to gravity. So we have gamma is equal to g times rho. Gamma is equal to g times rho. Now we can see the influence of the factors which affect, influence of factors on specific weight. Now from this relationship, we have already discussed about the factors affecting mass density. So the temperature has got an influence on mass density. The pressure has got an influence on the mass density. So with increase in temperature and pressure, the mass density of a gas increases. With increase in temperature, the mass density of a liquid decreases both because of increased molecular mobility. Now the specific weight depends on the mass density as well as acceleration due to gravity. Now acceleration due to gravity, is it a constant? G, is it a constant? So if I ask the question, most of you will tell it is a constant. Of course, maybe at Chidambaram it is a constant. Maybe if you go to the Arctic pole or Antarctic, it will be different. So at the equator it is different. In the poles it is different. So if you take the globe, the G value varies from 9.78 meter per second square to 9.83 meter per second square. So all around the globe, it varies from 9.78 meter per second square to 9.83 meter per second square. So if not given, suppose if a problem is asked, a numerical problem is asked to solve, for you to solve in the examination or whatever it is. So if the G value is given, you have to take that G value. If the G value is not given, let us have a value equal to 9.81 meter per second square as the standard for our conditions, for our place, 9.81 meter per second square. Now what is the physical meaning of this G? What is the physical meaning of this G? Now where the G is maximum? The G is maximum at the surface of the earth. Whereas if the depth increases from the surface, suppose if you are going towards the center of the earth, the G value decreases. So G is maximum at a particular place, G is maximum at the surface. When the depth increases from the surface, that is beneath, the G value decreases. Similarly, the G value no, it is acceleration due to gravity. So for example, a object is dropped from a height. So in the first second, say it is dropping from rest, an object is dropped from a height towards the ground. Say an object is weighted at elevation some say 1 kilometer, for example, 1000 meters from the surface. I am dropping that object, it has got a weight, I am dropping that object from that point, from rest. So it is traveling, because of gravity, it is attracted towards the earth's surface. Now in the first second, that object, say it travels 9.81 meters. In the second second, it will get accelerated because of the force of attraction, and the distance it travels in the second will be 9.81 multiplied by 2, that is 19.62 meters. In the third second, again it will increase by another 9.81. So as it reaches towards the earth's surface, the acceleration of the object will be maximum. This is the physical meaning of how to understand the concept of acceleration due to gravity, 9.81 meter per second square. So 9.81 meter, so you can write this like this, say 9.81 meter per second. So the acceleration increases at the rate of 9.81 meters per second. So in the first second it is 9.81 meters, in the second, இரண்டாவது நொடியில் 9.81 becomes double, that is 19.62. Third second இன்னொரு 9.81 கூடும். So it increases at the rate of 9.81 meters per second. So there is the physical meaning or concept of acceleration due to gravity. So the acceleration due to gravity, it varies from place to place, as g is not a constant. Maybe at a particular place it is a constant, whereas if you go to a different place, there will be a slight variation. As I told, around the globe, around the entire Earth's surface, it varies from 9.78 meters per second square to 9.83 meters per second square. So the specific weight also varies. Then further, the mass density, we have already seen the factors influencing mass density. The mass density of fluid depends upon the temperature and pressure. Therefore, the specific weight also depends upon the temperature and pressure. So specific weight varies with mass density, variation in mass density as well as variation in acceleration due to gravity. So, but at a particular place, at a particular temperature and pressure, the specific weight or mass density can be considered as a constant. Okay. Now we are going into the third property, that is specific volume. Specific volume. Now specific volume of a liquid, then specific volume of a gas. There is a slight difference between these two in the definition. Specific volume of a liquid is defined as the reciprocal of specific weight or weight density of the liquid. So specific volume of a liquid is equal to reciprocal of specific weight. Reciprocal of specific weight. So again, what about the unit? So unit of specific weight is Newton per meter cube. So it is 1 divided by Newton per meter cube. So if you take, it becomes meter cube per Newton. So meter cube per Newton is the SI unit of specific volume of liquid. Then specific volume of a liquid, has units of meter cube per Newton. Now specific volume of a gas, how it is defined? It is defined as the reciprocal of mass density. So specific volume of a gas is defined as the reciprocal of mass density of the gas. So 1 by rho. So what about the units of specific volume of a gas? 1 divided by units of mass density is kilogram mass per meter cube. So this becomes meter cube per kilogram mass. Meter cube per kilogram mass is the unit of specific volume of a gas. So specific volume of a liquid is defined as the reciprocal of the specific weight of the liquid, and it has got units of meter cube per Newton. Specific volume of a gas is defined as the reciprocal of mass density of the gas. So it has units of meter cube per kilogram mass. Okay. Now the fourth parameter, specific gravity of a fluid. Specific gravity of a fluid. So specific gravity, the notation is S. We use the notation capital S. It is defined as the ratio between specific weight of the fluid divided by specific weight of the standard fluid. So specific weight of the fluid is defined as the ratio between the specific gravity of the fluid is defined as the ratio between specific weight of the fluid and the specific weight of the standard fluid, or it can be defined as the ratio between mass density of the fluid and the mass density of the standard fluid. So when you want to determine the specific gravity of a liquid, The standard fluid or the standard liquid we use, the standard liquid is water. So it is specific weight of water or mass density of water. So specific gravity of a fluid is nothing but it is a ratio of two similar quantities. That is, we are comparing the specific weight of the particular fluid for which the specific gravity is required with the specific gravity of the standard fluid. In case of liquid, the standard fluid is or the standard liquid is water, whereas in the case of gas, the standard gas is air or hydrogen at standard temperature and pressure. When it comes to liquid, the temperature is important. So we have to compare at a particular temperature, the same temperature. Whereas when it comes to a gas, we have to compare the specific weights or the mass densities at standard temperature and pressure, STP we call. Standard temperature and pressure. So in case of gases, the temperature and pressure are important when you are quoting the specific weight or mass density. Whereas in the case of liquids, the temperature is important, the standard temperature is important. So specific gravity of a liquid, the standard liquid is pure water at 4 degrees Celsius. For determining the specific gravity of a gas, the standard gas or the standard fluid which is used is air or hydrogen at standard temperature and pressure, STP we call. Okay. So let me summarize. We have seen 4 parameters till now: mass density of a fluid, specific weight of a fluid, specific volume of a fluid, that is specific volume of a liquid, and then specific volume of a gas, and then specific gravity of a fluid. We have discussed at length the factors affecting mass density as well as specific weight with regard to a liquid as well as with regard to a gas. Then we have discussed at length the SI units of measurement of mass density and specific weight, and also we have discussed on the dimensions. Now let us go back to the specific weight and derive the mass dimensions, that is MLT. In MLT system, the dimensions of specific weight. Now as I said, specific weight is defined as weight per unit volume. So weight is nothing but a force quantity. If you are using FLT system, then it is FL power minus 3. So I want to give the dimensions of specific weight in the MLT system. Instead of F, I should have M. So now let us take the relationship now. Let me create a white screen, new white screen. So we have gamma is equal to G times rho. Now gamma has got units of Newton per meter cube. Mass density has got units of kilogram mass per meter cube, and G has got units of meter per second square. Now let us express Newton from this. So Newton is equivalent to kilogram mass per meter cube into meter per second square multiplied by this meter cube. If you take it here, it will go to the numerator. So this meter cube and this meter cube will get cancelled. So you have Newton is equal to kilogram mass into meter per second square into meter per. Now what is the dimensions of Newton? Newton is a force quantity, that is F. The dimension of any weight or is F. So F is Newton, that is F. Then kilogram mass is the unit of mass, so the dimension of mass is M. Then meter is the unit of length, the dimension of length is L. And then S is the unit of time, that is seconds. So, second square will be T square. So, F you can express the dimension of any force quantity can be expressed in MLT system as F is equal to m L T power minus 2. So, what about the dimensions of specific weight in MLT system? So, specific weight again is defined as Newton per, it has units of Newton per meter cube, that is F L power minus 3 or F by L. So, F can be replaced by what? M L T power minus 2 into L power minus 3. So, this becomes L m into L power 1 minus 3 T power minus 2. So, this becomes L power minus 2 T power minus 2 or m divided by L square T square. So, this is what the dimensions of specific weight in MLT system. So, m, it's again I go back and explain again, Newton per meter cube is the unit. So, unit of, dimensions of force is F, the dimensions of volume is L cube, that is it becomes L power minus 3. So, dimensions of force is m in MLT system is ml T power minus 2. So, ml T power minus 2 into L power minus 3. So, it is m L power 1 minus 3 to T power minus 2, it becomes m L power minus 2 T power minus 2. So, we have F can be expressed as m divided by L square T square or m L power minus 2 T power minus 2. Okay. So, let us solve a basic problem to understand the concepts better and to familiarize with what we have discussed so far. So, it is an example, a problem. So, the problem states if 5.27 meter cube of a certain oil weighs 44 kilonewton, calculate the specific weight, mass density and specific gravity of the oil. This is the problem. So, let us first list the data with the proper notation as, so what are the data that is given? So, 5.27 meter cube is, it speaks about the volume of oil. So, volume of oil, let us use the notation V, that is 5.27 meter cube. It weighs, so that 5.27 meter cube of oil weighs, that is weight of oil, it is given 44 kilonewton, that is let us express in newtons, 44 into 10 power 3 newton, because 1 kilonewton is 1000 newtons, 1 kilonewton is 1000 newtons. So, these are the two data that is given, the volume of oil is given, the weight of that volume of oil is given. So, you are asked to find out the specific weight, that is gamma, mass density and then specific gravity of oil. These are the things that are required. Okay. So, let us now recollect how we define specific weight. Specific weight is defined as W by V, that is weight per unit volume. So, it is both these data are given. So, weight is 44 kilonewton or 44 into 10 power 3 newton multiplied by volume. So, you can work out the result, use a calculator and find out what is the result. So, it has got units of Newton per meter cube. So, I leave it to you to calculate. Then mass density. So, how to determine the mass density? Now, we can use the relationship, that is relationship between specific weight and mass density, this gamma is equal to G times rho. Let us use this relationship. Now, we have determined gamma, this is determined, this value is known, gamma is known. G, it is not given in the problem statement. So, let us take, if it is not given, let us take the value G is equal to 9.81 meter per second square. So G is also known. So what is the unknown? Rho is the unknown. So how to determine rho is equal to gamma by G. So gamma is known, G is assumed. So we get rho. What is the unit of rho? This value is in kilogram per meter cube. So this is kilogram mass. Gamma is in Newton per meter cube. G is in meter per second square. So this should be in Newton per meter cube. This should be in Newton per meter cube. So we get rho. Okay. And one more parameter that is asked, you are asked to find out the specific gravity of oil. So what is specific gravity of oil? Specific gravity, you can either use specific weight of oil divided by specific weight of water, or you can use mass density of oil and mass density of water. You can use any one of these because we know the specific weight as well as the mass density. So specific weight is known. Specific weight of water, again, let us assume it's not given. We will take it as 9810 Newton per meter cube at 4 degree Celsius. Nothing is told about the temperature, so we will assume the temperature as 4 degrees Celsius. So instead of this, if you are using mass density, if you use mass density of oil, then you compare with the mass density of water. So rho W you put as 1000 kilogram per meter cube. Okay, and get the specific gravity. So I am not going to the final answers. I leave it to you to as an assignment to work out the values. Now another problem, again on the utility of these in understanding the concepts, the properties we have discussed better. The specific gravity of a liquid is 3. What are its specific weight, specific mass and specific volume? So what is given? Only the specific gravity of the liquid is given, 3. You are asked to find out the specific weight, specific volume, and then specific mass. Specific mass is nothing but the mass density. Specific mass is nothing but the mass density, the other name for mass density. So these are the 3 things to be found out. Now the specific gravity is given. So specific gravity means specific gravity is equal to, as we discussed in the previous example or problem, it is the ratio between the specific weight of the liquid and the specific weight of the standard liquid, that is water, or mass density of the liquid with mass density of water. Now we can use any one of these. Now 3 is equal to, let us use this one. So specific weight of the liquid divided by specific weight of water is 9810 Newton per meter cube at 4 degrees Celsius. So from this you can find out gamma. So gamma is equal to 3 into 9810 Newton per meter cube. So you get the specific weight. Now once you get the specific weight, we can find out the specific mass. So using the relationship between the specific weight and mass density, as gamma is equal to rho G. So gamma is known. G, let us assume it as 9.81 meter per second square. So therefore rho is equal to gamma by G. So this will be in kilogram mass per meter cube. Okay. Then specific volume. So specific volume of a liquid, how it is defined? Specific volume of a liquid is defined as the reciprocal of specific weight of the liquid. So specific weight we have already determined using this. So you can put 1 by gamma and report the result as so many meter cube per Newton specific volume. So let me summarize what we have discussed in module 2 today. So first I listed what are the various properties we will be discussing in the chapter on fluid properties, and today we had discussed on 4 properties: mass density of a fluid, specific weight of a fluid, specific volume of fluid, and then specific gravity. And we have worked out 2 sample problems in order to better understand the concept, and also we discussed on the units of measurement, SI units of measurement particularly, and then the dimensions, that is using MLT system or FLT system. And also we have discussed the factors affecting mass density as well as specific weight, and we even discussed on the physical meaning of the acceleration due to gravity, the physical concept of that, and hope you have understood better these concepts. And in the next module we will start on viscosity of a fluid. So with this, goodbye, thank you.